Welcome everyone, and thank you for attending today's webcast, an introduction to Inventor's frame generator and 3D sketching. Our presenter today is Kendred Cooper. He's a solutions engineer with Hagerman and Company. Before we get started, I want to let you know that you're in listening only mode. If you have questions during the presentation, you can type those into the question panel on the right-hand side of your screen, and they'll be addressed at the end of the presentation. As we close down the session today, you'll be prompted to fill out a survey. We ask that you take a few moments to fill that out. Additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. With that, I will hand things over to Kendred.
Thank you, Ashley. Welcome everyone to today's presentation. As Ashley mentioned, we're going to be talking about, wrong title. That's this sheet metal webinar. Actually, we should be talking about the frame generator. So I'm on the wrong presentation. Let's try that again. Okay, here we go. We're going to be talking about the frame generator and 3D sketching. I am your presenter, Kendred Cooper, and in the background we have Kevin Bosch, who's going to be addressing the questions and answer section. And we are going to have some designated time at the end of today's presentation to cover the Q&A. So let's get right into it. This slide is obviously for people who cannot hear me, but it's also a good slide to showcase the Q&A panel. Should pop up with the GoToMeeting manager that came up when you logged into the meeting. So you can enter your questions into this panel and Kevin's going to address them as we go through the presentation. And again, we'll have designated time at the end of the presentation to address them as well. So jumping straight in, frame generator, what is it used for? There's a lot of different uses that it has. In industry, you're primarily going to focus on structural framing for machine footprints. That's really what it's designed for. You've got a couple of other offshoot industries that it can fit into, things like jig and fixture rigging, the framework for that, framework for small structures. We're talking things like a lean-to or a storage shed or test stand or test equipment, things of that nature. Rigging for trailer beds, car haulers, things like that. It's right up that alley for those types of situations. When you're talking with structure framing, again, stressing small structure, we're keeping the pieces or the overall footprint of the structure down to a minimal. You don't want to take this and try to model up a 20-story apartment building. Various reasons for that. Can Inventor do it? Sure, but how much time are you going to spend trying to do an Inventor versus something else that's more tailor-made? So it's got a lot of uses in industry. So what it's not designed for is, like I mentioned, something like a high-rise office complex, apartment building, something like that. The reason it's not designed for that situation, let's say your job is to make video game characters and you've got AutoCAD. Can AutoCAD make a 3D video game character? Yeah, it can. It's got the shapes and ability to do that. Can you move it? Sure, you can move it and take still images and eventually make a movie of the character walking. How long are you going to spend trying to do that? That's the same thing here. If that's your job and you need to make a game character, there are more tailor-made products for that, things such as 3D Studio Max or Maya. Same situation applies here. If your job is doing large-scale structural framing, there are other tools that are more tailor-made for that. Inventor can do it, but it will end up taking you longer in Inventor as opposed to the other two tools such as Revit Structure. So a large-scale building structure, you don't want to tackle it with that. The other things you might want to consider are things like rigid pipe connections or flexible tubing type situations. There are structural shapes in the frame generator for tubing. Those are really intended for things like handrails and ladder guides and things like that. If you're looking at piping and tubing, then another tailor-made product is going to be Inventor Tube and Pipe. So if you're looking at something here, like here in the center, could we do this with Inventor, with the frame generator? Sure. Would I rather do it with tube and pipe? in Inventor, yeah, that's a much more suited environment to tackle a design like this. The other benefit with tailor-made or specialty packages like Revit Structure for the structure on the right, Revit Structure will automatically do coping, and part of that utility, you tell it what size flange connector you want to use, what type of flange connector, if it's a T or an L bracket, how many bolts per side or how much loading, what configuration of bolts. All of that is built into the utility that's going to notch out or cope out this piece, apply the flange, apply the fasteners, and it's done. One utility, one-stop shop. That's the benefit of a tailor-made product like that. With Inventor, we could still do this, but it's going to be a manual process. It's just going to take us longer to do it. So getting to the basics of this, framing 101, the way to approach this through Inventor, you start by either creating a 2D or a 3D sketch, or you can create a solid model or a surface model. Most commonly, you're going to go with a 2D or a 3D sketch. That becomes your skeletal model for the modeling process. So if you look over here at the lower left-hand corner, we have a basic skeletal sketch part. Now what this actually is, it's a 2D sketch on top and a 3D sketch for the legs and the cross members. It could have been multiple 2D sketches. The software is flexible. You're not stuck into one workflow. So that's going to become the basics and the foundation of your framing assembly. You can also use a solid model. So what we have here on the right-hand corner, this represents the overall footprint of a 10-foot by 15-foot horizontal machining center. This is just the overall shape of it. No real details, we just have the basic shape. Those edges become the framing centers. So we can use those edges, and you can also do point-to-point frame alignment instead of just edges. The same principle applies if this is a surface model instead of a solid. You're still allowed access to those edges to use them as frame centers. And then also you can take your own custom shapes and publish them. Everybody's familiar with the almighty 80-20 shapes. So you can take those shapes, publish those into the frame generator engine as well. What you get out of the box are pretty much your standard shapes. You've got your I-beams, W's, L brackets, T brackets, round, square, and rectangular bar stock, and solid or tubing stock and solid bar stock as well. So if you need something custom, you can certainly plug that in and use that. There is a utility for your custom shapes. If we have time, I'll certainly fire that up and show you a little bit about it. The shape author comes with your Inventor. You have to create a read-write library in your content center. That is critical. Without having a writable library in your content center, you're not going to be able to publish anything, whether it's this or pieces into the content center. The content center libraries by default, all of the stock libraries are read-only. You can't write any changes to them, so you have to create your own library. If you need help with that, certainly contact us. We'll be happy to help. Then you sketch out your frame shape and do a simple little extrusion. Now you've got the basics to get this published. So what can the frame generator do? Well, you've got the steel industry, like I mentioned, for handrails and framing and I-beams and things like that, but you also have non-steel or non-metals industries it can get into a little bit. Previously, I mentioned that you don't want to model up anything that's like a large structure, but smaller structures are certainly feasible. You've got things like storage sheds and lean-tos. The storage shed that's in my own backyard, I modeled up with Inventor Frame Generator. Right now, I'm actually working on redoing my back deck and doing the same thing, using the frame generator to lay out all the pieces, get cut lengths, get an overall build plan going, and I'm using the shape author to publish in 2x4s, 1x3s, 2x6s, things like that, things that are not part of the standard content center shape library. It's flexible to work across multiple industries. So let's just get right into it. Switch over to my other screen. Okay, so what we're going to be looking at is we've got a large platform here, and this is perfectly suited for frame generator. You've got a lot of different frame members going on. You've got the underlying structure down here below. You've got the framework to support the platform, the walk pads. You've got the stilt structure, the beam structure to support that, the cross members. You've got the stair railing, the stairs themselves having the base of the stairs, the railing for the stairs, and then the safety rail up the top. All of this is right up the frame generator alley. Everything in here you see can be done with the frame generator with ease. So what you start with is a piece part with some sketches in it. So I'll start out with this guy. Actually, that's wrong one. I need the actual piece part. There we go. So what you're looking at is just a basic 2D sketch, nothing fancy, nothing special. Standard sketch, constrained properly, centered. From this, that's the bare minimum you need. You can throw that into an assembly and you can start applying frame members to it. But I'm not done with it. I need some legs and cross braces on this. So I'm going to use this piece part and cover the 3D sketching portion of our webinar. So when you launch your different sketch environments, you have 2D sketching and you have 3D sketching. When you go into the 3D sketch mode, this is where a lot of people start to sweat, because it's very foreign to us. We're not used to coming in here utilizing this environment. It kind of throws us a curveball. Our brains are already used to thinking in a 3D mode, but we're not used to working in a 3D mode interface. And that's where it throws us for a curve. So you've got some familiar commands in here out of the 2D sketch environment. You have line, you have arc, bends, points, dimensions, constraints, trim, extend, split, a lot of familiar commands, and then some that are kind of unknown. These different unknown commands, obviously they're going to bring you different capabilities to utilize in the environment. Things like a helical curve. This allows you to create a helical curve for a spring type situation or a screw thread type situation, or even a wound clock spring type situation. And you can create that sketch line and use it to sweep geometry along that path. For here, we're going to start sketching out the lines for the legs of this platform. And what I want to go through are some of the more advanced commands, just to let you know what is capable inside the 3D sketch mode. So for example, when you look at some of the advanced command structures, one of the commands is an intersection curve. And while this doesn't necessarily apply to something like frame generating, it does apply to shape manipulation. So when you go into 3D sketch mode, the intersection curve allows you to take different sketch elements or even projected sketch geometry. It doesn't have to be scratch drawn geometry. And what it's going to do in this situation, it's going to look at this top sketch curve and it's going to project it back in the -z direction. Then it's going to look at the back sketch curve. Both of these are just 2D sketches on different planes and orientations. Going to look at the back 2D sketch curve and project it up in positive Y. Where those intersect, it will create the geometry as a 3D sketch curve. So how do you utilize this? Well, for something like this, you can utilize this in the loft command. So for example, if you loft between the two base sketches, you end up with a lofted surface that gives you some nice contours and curves that you can use for creating some geometry. But if you then incorporate that 3D sketch curve that was created in the sequence of the loft, you end up with a much more dramatic shape that you can then utilize for, again, additional surface or solid modeling. What this actually is, it's the start of a gas tank on a Honda motorcycle. So if you look at it from the side profile, you've got the rider back here on the right-hand side and the handlebars up here on the left-hand side. So you can utilize something like that to get a much more advanced shape definition. Some of the other features inside the 3D sketch are command structures that allow you to utilize sketches and surfaces, even solid surfaces, not just surface geometry, but you can utilize the commands such as project to a surface. What this allows you to do is you can choose a set of curves. It'd be better if they called them sketches, but curves work. So choose your set of curves, then choose the face that you want to project those curves onto, and you've got some options. You can project just along a vector direction, so it's going to project these perpendicular to your sketch plane, to your 2D curve sketch plane, or you can project to a closest point of the surface or even wrap them to a surface. So when I hit OK, what it actually ends up providing you is wrapped around that cylinder, you see how it projects those curves straight through. This gives you a path. This gives you a continuous path that you can use to sweep along, to cut out a groove, a follower groove, maybe even do some surface manipulation to cut this area, cut out a pocket for a tool rest, or who knows what kind of geometry you're going to be working with here. Another one of the options is to take a set of curves and wrap them around the face. This is also handy if you have a particular arc length or line length and you need to see it wrap around a surface until it runs out of length. So that's actually what's going to happen. When I choose the face, it wraps the arc continuously around until it runs out of room. Now, what happens if the arc gets longer or shorter? Well, with an update command, the result is going to change. So if I shorten down the arc and change the curvature of it, when I hit my local update, you'll see the resulting projection changes. So these are associative back to the geometry. They're not just static projections. They work just like project geometry does. So in the 3D sketch environment, you've got additional tools to help you manipulate that geometry. The first thing that probably throws a lot of people when they come into that environment is the introduction of the little gizmo guy. So when you go into the 3D sketch environment and you start the line command, for example, you'll notice at the origin, there's been various names given to this. It's changed identity a few times over the past releases, but 3D gizmo seems to be what sticks from version to version. You get this little 3D gizmo display, and it allows you to control how you're going to sketch. Now, we're sketching something just as simple as a line segment. So what you're allowed to do is you can pick any point out in space, and then you can choose what orientation you want this line segment to go. So right out the bat, if I just start sketching at 0, 0, my endpoint is going in all three directions, X, Y, and Z. I have no real control over where it's going to end up unless I utilize some of the sections and features in the gizmo. So for example, if I highlight and select this plane here, it's going to confine my line segment to the XY plane. So now I'm only worried about two directions. Same thing if I do here on the bottom plane, it's going to confine it to the X and Z direction, or X and Z plane. So you can choose that plane and it will stay in that planar orientation. Now you can just look flat to it and it's just like you're sketching in a normal 2D sketch that you're used to. So you can change what plane direction at any time. So I'm going to sketch out just a few line segments here. All right, so at this point, I'm going to now change my orientation and confine it to the XZ plane direction. Come out just a little bit, step it over, maybe down to here, and then change again, go to X and Y, or sorry, Y and Z, and then X and Z, and go back to Y and Z again. And you can dimension each one of these segments relative to that plane orientation using the dimension command. And what you'll see is the result of a 3D sketch. This can be used for laying out piping, tubing, wiring, handrails, anything of that nature. So that's really what throws everybody when we first come into the 3D sketch environment, is the gizmo and how to use it. You can even start using the X, Y, and Z axis or vector directions to lay out your start point. You don't have to start at 0. What if you need to start a certain amount away from 0 in X and a certain amount up from 0 in Y? You can use that box to do this. So maybe we start 1/4 inch over in X and 1/8 of an inch up in Y. Z is 0, so that's where that start point is. It moves the gizmo to that location. So try not to be afraid of the 3D sketch environment. It can be a very handy tool, especially when you come in to do something like framing. So jumping back to this, we're in the 3D sketch mode inside of this part, and I need to reference pieces of geometry in here. Just like you have project geometry in a 2D sketch, in here we have include geometry, and it creates that reference point for us. So I'm going to reference each one of the corner points of my 2D sketch of my frame, and then I'm just going to draw my line segments. So coming down from one of them, choosing an orientation, making sure it's 90 degrees, and I'll bring this one down. Not worried about the dimension just yet. And I want to restart this and do the same thing on all 4 leg corners. Once I have them all drawn, I can then go back and utilize constraints to lock in the relationships. So I'm going to select each one of them, or select all of them, and then I'll just set them to be equal with each other, and then I'll throw a dimension down. So these are going to be 84 inches long. Now I need to put in some cross members just to give this some rigidity on the design. Same thing here, I'll just go from midpoint to midpoint, restart my line segment, and then midpoint again to this midpoint. Now, when I get into the frame generator itself, it's going to see these 2 segments here as continuous runs. And I'm not going to have the flexibility I need to do proper frame notching. So what I'm going to do is I'm going to take one of these line segments and I'm just going to split it up. So luckily we have the split command in the 3D sketch environment. So now I've broken that up into 2 separate segments. I can now use this as my base model for my framing. So all you have to do is you launch a standard assembly or weldment. Either one you want to work with is fine. Depends on what you're going to do, if you're going to apply welds or not. Once you're in the assembly mode, you're going to place the skeleton component. Then you use your standard assembly workflow to get the proper orientation, place it grounded at the origin, and of course, save your assembly. Once you have the assembly saved, on the design ribbon, you have a frame panel. This is where all of the frame generator interaction is going to come from. And again, it pulls from the content center. So if I just bounce in there real quick to show you what we're going to be pulling from, standard content center, you have a structural shapes category. Under there, you have angles, C-channels, I-beams, bar stock, square tubing, T-shapes. It's pulling from each one of these categories for the frame generator. And again, you can create your own custom category in here in a writable library and publish your own custom shapes to that. So I'll start out with inserting the frame. The frame generator brings up this dialog that looks pretty busy, but it's pretty simple on the workflow. You're going to be determining what standard you're going to conform to. ANSI for us, we're going to keep it easy. And then what family you're going to be working with. So going all the way to the top here, we've got flat bar steel, then we go into rectangular tubing, square bar stock, square tubing, rectangular tubing, different standards of square tubing, round tubing, I-beams, H-beams, S-beams, and then you get back into piping. And you've got different categories for different standards. You've got metric and inches. So what I'll be working in is the S-shape or the S-beam. Then you choose your size. So for this, I'll just use a 3x5. Then you can optionally, you're not required to, but optionally you can pick a material and then a material finish. The rest of the dialog box deals with the actual placement and control of the member itself. So looking across the bottom, you've got the different abilities or different ways you can select to place a frame member. The default method is to insert a frame member on a sketch line or an edge. Same thing seen by the software. The other method is to say point 1 and point 2. Wherever those points are, it'll put a frame between those 2 points or connecting with those points. Then across the very bottom, you've got different options for being prompted for the file name of the member, because it's going to create an actual part, just like you're placing a part out of the bolt out of the content center. It's creating an actual bolt. So it's going to prompt you for the file name and location. You can have it choose to get the part number and material and everything from the content center if you wish. And then you can choose what sketch lines you want it to see access to. By default, it's going to see solid sketch lines, center lines, and construction lines, but you can filter that out to where it only sees 1 or 2. So I'm going to select my 4 vertical legs here, just with a crossing window. And then I will look at the orientation section. The way this works, the little target that you see in the dialog, that represents your sketch line. So if I look flat to this and come up here and look at my preview, you'll notice the S-beam or the I-beam is centered on my sketch line. So if I change my orientation and put it at one of the corners, for example, it changes to relocate it at that corner. So you might look at this and say, well, wait a minute, that doesn't match the preview. Okay, it will if I flip it around and upside down. This is where it can get a little bit confusing sometimes. Oh, I need to go to the other way. It can get just a little bit confusing if you're looking at the wrong side, at the wrong end, and the wrong orientation. It's going to depend on where you pick the sketch line to determine which is the top end, which is the bottom end. So it may not match your preview orientation. Me personally, I usually don't worry about it, because you can come back later and you can change that orientation. A lot of times I will just center everything and then come back and move each individual piece the way I need it to move. Because right now, if I want this to go to the inside, picking the inside corner of it, now I can offset it inside if I want to. So if we look at this sketch size, 156 by 104. Let's say that's the overall size of our platform. We cannot exceed that. We're under a space requirement. So if that's our overall size, and we're going to wrap the top of this in 1/8 inch thick sheet metal, about 12 inches wide. It's going to be just a sheet metal skirt. Okay, in order to do that, we need to move this I-beam in just a little bit, right? It can't be on the very edge, because then we'll exceed the overall footprint. So that's what these 2 offset boxes are for. They allow you to control the distance offset inside or outside. The distance can be positive or negative, so you can control that gap. So this gives us our gap space for the 1 inch or 1/8 inch thick sheet metal skirt that we're going to be putting on this. For simplicity's sake, on the edits that are going to come later, I'll just set this back to 0. You also have control to rotate these pieces. Now, the way this is currently set up, it's going to rotate each and every one of them or offset each and every one of them. This is one of the reasons I like to just apply them centered and then come back later and change them. So that's probably the workflow I'm going to use. When I click OK, you'll see I'm prompted with a subassembly name. So this works just like the bolted connection generator. You place a bolt, washer, another washer, and a nut, and it's going to create a subassembly within your top level assembly. The same logic applies here. You're specifying the subassembly, the path to that sub, and then the skeletal frame component part name and path for that. When I say OK, then it's going to prompt me for the file names and the paths for each one of these members. Even though they're the same size, the same length of I-beam or S-beam, it's going to make each of them a brand new piece part. Okay, it's going to reuse the data from the content center and just give them a new name. So for this one, I'm going to say each one of them and start the sequence over at 1. So this one will be 02, and the next one 03, and so forth. The reason it does this is because of the edits that you're going to do to the components or the frame members afterwards are going to be unique. So if you reused the same frame member, then the edits are going to be on all of them, and it may not be the right edit for each one of them. So I'll go ahead and create those. Got the start of my platform going here. The next thing I need to do is come in and change orientation, right? So I've got them all centered. I want to change these members and relocate them. That's where the change command comes in. You're able to select multiples to change multiple pieces at once, or you can just work one off. So for this one, I'll change the orientation to the proper corner location, and I'm going to offset it in for that sheet metal, and make sure I have my gaps correct. All right, one of them's going the wrong distance, so I'll just negative that. Apply that, and I'll keep making changes to the rest of the pieces to get them to the proper orientation as well. Same thing, putting in the sheet metal offsets, and again, both of these will be negative. Okay, that's actually the only two I'm going to worry with for now, for time's sake. Need to insert a few more frames, so I'm going to insert my cross members down here at the bottom. It's going to be 3 pieces, because again, I split that one cross member line, keeping all of the same options, same material, same size. You can change them if you want. The software is not going to resist that. You can mix and match any frame shape and any frame size. Again, it's going to create 3 unique parts. And when I say unique, they are unique. You can open them individually and make edits to them. That's going to be very apparent with what I'm about to show you. When we zoom in and we look at how these frame members are going together, this one back here is kind of driving through one of the legs. Okay, that's not going to work. We got to cut it down and match it up. To do that, we have a tool called Notch. Now, this is what I was referring to that Revit Structure does automatically. With Revit Structure, you run a cope, and it will automatically cope and then ask for mechanisms on how to secure this connection. With Inventor, it keeps everything small. They're assuming you're going to weld pretty much everything in here. That's what we're doing with machine framing. We're welding 99% of it. So you're not prompted with any kind of bolted connection or fastener connection or reinforcement connection. The way the Notch command works, you choose the blue part is what's going to get cut or modified, and then the yellow component is what it cuts into or cuts to match that shape. So I'll go ahead and say okay here. And when I say okay, it doesn't look like anything changed. Hey, you still got that piece sticking out there. Well, it did notch it. It did cut it, because you'll notice there's no preview lines going through the vertical beam. All of these members, they are standalone parts. Remember, I said that a few minutes ago. That's very handy because you can open these individual pieces and take a look to see what changes have been made to it. And when we come in on this end point down here, you'll notice it has completely notched out and cut out the shape of that I-beam that this is running into. So what do we do about this extra leftover material? Okay, it's real easy to take care of at the part level. You can use something like the delete face command, void option, choose that lump of material, and it's gone. It's out of the way. Save my part, instantly go back, update my assembly. You'll notice the leftover material is gone. Now, the other thing that you might need to compensate for in here, if you're going to weld this together, you probably need a little bit of a gap between these faces. So again, this is why it's an advantage that these pieces are standalone pieces. You can take these pieces, right now, these faces, there are no gaps between these faces. You can take this piece, open it back up, and you can offset these faces so that you can mimic or create a weld gap. So for that, I'm going to use the thicken and offset command, just picking each one of these faces to offset them. And instead of offsetting them outward, I'll offset them inward for an 1/8 inch gap. Save my part, close it, update on my assembly, and you'll see there's a gap already in there. So this is why you get that ability to have them as standalone parts. I'm going to insert the rest of the frame members up here at the top, just picking my sketch lines. You can window to select sketch lines or select individuals. I'm still going to stick with the same shape for now. And in just a few seconds, you get all of your frame members. Again, we got some cleanup we got to do on these. So looking at the corners, we've got a situation where, okay, well, I need to offset each one of these in. All right, we can do that, not a problem. Just change that member, change the offset area. Same thing to this one, change the orientation, and continue to do that all the way around. It might be a little bit more time intensive to do it this way, but my personal preference is I get the flexibility of how I want to handle each frame member after I get them laid out on the skeleton. Okay, so looking down here at this end connection, we got a nice little conglomeration of stuff going on. First off, let's start out by mitering the two top pieces of the platform. So with the miter control, you're mitering two pieces, but you do have more control than what you have in the notch. In the miter, you are capable of specifying a weld gap. It defaults to 0, but you can go in and specify whatever you need. You also have control to specify that the miter is clean cut on both, or one gets cut and the other one just gets angled, basically, a one-off miter. So I'm choosing a symmetric miter. It miters both pieces perfectly and puts in that weld gap that I had. So how do we handle this guy here? Do we do another notch on the vertical leg? No, you don't have to. You could, but it's an extra step to go in there and delete this extra bit of material that you don't need. So for something like this, you can use the trim extend command. So the way this works is you're choosing multiple pieces if you want to cut them all at once. The notch command is one at a time. You can cut one frame to match this, cut one frame to match this. The trim and extend allows you to pick multiple things to cut at once. So all I really need to do is shorten this guy, right? So I'm just going to pick the vertical leg here, and I'll actually pick all of the vertical legs since they're all going to be cut the same. That's going to be my blue selection, the piece that's going to be modified. And then I choose the face that I want to shorten them down to or lengthen them up to. So that's going to be the bottom side of the I-beam here. Say OK, and it shortens all 4 pieces. Now, if you'll notice in the tree, as you're making these edits, these pieces get all of these end treatments added underneath. Whatever modifications you've done to it gets added down here, almost like a feature that was done to it. You can change to mix and match shapes, change and mix and match size. So if I want to change from an I-beam type shape to maybe something like a rectangular tube shape, change to a different size tube, and we'll maybe go up to we'll say a 4x2. Same thing here with the frame members. You can notch out to match up shapes. So if I notch out the rectangular tubing to match up with the I-beam, or if I shorten, I can also lengthen and shorten. The downside to this on the trim and extend, if I'm trimming the rectangular tubing to the inside face or the back face, we'll say the back face here at the top, it's going to shorten the tube too much. Okay, that's not going to work out. So I will have to use something like a notch for this. But in this situation here, do I necessarily need these areas of the rectangular tube up top? No. Again, that's where it's handy because these are standalone pieces that you can open and you can make your edits onto these standalone pieces. So for something like this, I may come in and create some extrusions and cut away that material, or just use a work plane and split it and break off those pieces, whatever way works. That way I don't get that extra material left over on the top and the bottom. If you're working with a part as your base, okay, so if we got a machine base, again, this is just a solid part. It's just got the right footprint size, feet by feet. If we're working with this as our base, the workflow is the same. You're going to start with your assembly. You're going to place that machine footprint, proper orientation and location. Again, saving your assembly because it's going to prompt you if you don't anyways. Then on the design ribbon, you start inserting your framing. When you're working in a situation like this, you've got the ability to make rounded corners. It will round that beam. Whether you can bend it like that or not is another story, but it will round that beam for you, and you can also merge those pieces into one. Without that, it's going to break it up into 3 individual pieces. But with the merge enabled, it's going to be one continuous piece that it assumes you're going to bend it out in the shop to match it up. So when you're doing something like this, you want to take that source part, that source component, and you want to change the bill of material structure of that source component. And I'll show you why in a second. So just in a few seconds, you get all the frame members inserted into the assembly. You don't need the base component anymore, right? You don't need to see that. You just need to see the framing. So yeah, you can take and you can turn off visibility of it. That's one way to get it out of the picture. The problem is when you look at your eye properties on your assembly, that base component is still playing into these eye properties. It's having an effect on your mass, on your volume, your center of gravity, your inertia. You don't want that to happen. So what you can do is in the assembly or even in the bill of material properties of the part, you can change the bill of material assignment of that skeletal component part of that base component. Instead of being a normal BOM structure, change it to a reference. A lot of people don't realize that reference parts, anytime an item is identified as reference, its mass is not calculated when it's in an assembly. Its volume is not calculated. Its center of gravity has no influence over the top level assembly. So now your eye properties will adjust to only reflect the actual frame members. And this is also a good time to note on the bill of material itself, the information that you get out of this. You're given the overall length. When you miter something or when you cut something, the length adjusts based on that miter or based on that cut. So your cut length here is going to be exact. Any kind of offsets that you do, gap in or gap out for a weld, it's going to compensate for those as well. So the next thing to look at is the custom shape. So as we mentioned, everybody is familiar with or hopefully everyone is familiar with the 80-20 shape. Has gained a lot of popularity in the last 10, 15 years. So we're seeing more and more odd shapes, not just this, but other shapes entering into the market as well. Those are not in the standard content center. So you have to create those shapes and get them in there. Once they're in there, you can use them all day long, just like a regular I-beam, C-channel, bar stock. Here's the process, the basic process to get to that. Step one, you are going to have a writable library. You'll know if you have that if you look at your project manager. On your active project, in the lower right-hand corner, you'll see an icon labeled Configure Content Center Libraries. When you launch this, it'll show you all of the different libraries you have associated to your project file. One of those should be something like a My Library. This is the default stock out of the box library that gets created. But you can create a library and name it whatever you want to name it. It just has to be a read-write library. Without that, none of this is going to work. Once you have that set up, you've got your component sketched out, you got your component modeled. On the Manage ribbon on the Author panel, you'll see a pull down for authoring components to the Content Center, authoring tube and pipe shapes for the tube and pipe engine, or structural shapes for frame generators. So that's what we're going to utilize. Brings up a handy little utility. You can go in and choose your category. You can add it to an existing category, or you can use the Content Center editor and create your own category. So I've got an 80/20 category I've already created. It recognizes the shape. It recognizes a lot of the features. The only thing it really needs is some parameter mapping. The base length, you need to have a parameter that's already named or set up to represent the base length. So I just called mine length. Bare minimum, that's all you need right there, and you're ready to rock on to the next stage. You can put in other things like coefficient, shear displacement, moment of inertia, height, width, things like that. Pick and choose, kind of play around with this, whatever's going to be beneficial to you guys. Take a couple of test parts and try it out and see how you're going to like it and see what properties you're going to need in there. That's my best advice. Publish now brings up the author dialog boxes, choosing what library you're going to publish this to. You can have multiple writable libraries set up. You're not limited to just one. Then you get into the actual category assignment where you're going to place this. We're going to throw it in the 80/20 category. Again, it's just a review of your properties. If you need to add any more or map out any more, you can do that at this stage. And then what columns do you want to be present in here? Part number, material, pretty standard stuff. Length is standard. If you want to tweak more of this once it gets into the Content Center, then you're going to need to add some of the more critical information like the height of the profile, the width of the profile, or any other critical areas, bend radius, or some kind of critical fit dimension that's in there. You're going to have to add those parameters in the mapping. So I step into the next part of it. You're able to specify the family name, a basic description of the family as it's going to appear in the Content Center, what standard it's going to adhere to. This is pretty critical when you start filtering out the Content Center stuff. If you don't have a standard specified for a component you've published, it's going to disappear with every single standard that you filter out. So you want to assign it to whatever standard governs it. So when you look at the ANSI, that's all you're seeing, and you're going to have your custom components show up. What standard that it may adhere to, if any, what manufacturer, standard revision, all of this is pretty well optional, but I would definitely enforce and reiterate standard organization. You definitely want to specify that. So when you filter the Content Center, you see the components you want to see. When I jump into the next, you get a preview of the thumbnail image and publish it. Publish is already done. So how well does this work? Let's jump back to this guy and we'll just delete that assembly and start over. So turn off the visibility, or turn the visibility of that back on. Go back to my frame generator engine, insert a frame. There's my ANSI standard. There's my different shapes. You can also pull in different types of shape configurations to match. So like if you open up from the Content Center, open up your 80/20, you can mix and match that 80/20. Even though it's a custom shape, you can mix and match it with any of the other standard shapes. We will run into a footnote of, I've seen 2 instances where a custom shape did not want to miter correctly, and it's just because it was so exotic. It's a shape I've never even seen. It was so exotic it just would not miter properly. That was a couple of years ago. Autodesk may have fixed it. I haven't tested that. And I think with that, that's going to conclude, and we're going to open it up for questions at this time. So Kevin, how's the question panel looking?
It's been pretty quiet. Ben had a couple of questions about how very similar identical parts are grouped together with regard to parts lists, cut lists. I think I've answered those, and if you can look at my answers, you can kind of expand on that if you'd like to. There hasn't anybody else have any questions that they'd like answered?
Okay, so you're talking about the one, would each of those legs have an individual line item in the cut list?
Right.
Yeah, they'll each, appear as an individual line item, but with BOM editing, you can roll them into one line item if you want to in the assembly. Also, if you do roll them up and then you come back after you do that and you make an edit like I did where I used delete face and I removed a voided material, it's going to take that one item out of that line item because the length property just changed. So it looks at a couple of different things when it rolls them up. It's probably going to take that one item you make the edit to. If the length changes any, it's going to pull it out of that roll up and it'll exist as its own standalone item.
And next question is a link to the recording, and yes, there will be.
Yes, Ashley, I believe that is posted on our website within a few days. Is that correct?
Yes, it will be, and we also will email anyone who attended or registered for the webcast probably tomorrow with a link for the recording.
Very good.
Can the part names be changed to follow a part numbering scheme set up with Vault Workgroup instead of the default part numbering? The part number is pulled from the Content Center. So whatever you have listed there, it's going to follow that sequential setup. Now, once you get this into Vault, you can renumber parts from there. As we place it, there's no way, they don't have it in the software to pull a queue or reference into a Vault table to say, get your part number from here. It has to be mapped into the Content Center in the fashion you need it. It might be totally off topic. If I have a 12 gauge round perforated panel and need it to be formed into a seat panel, that is something I can achieve with 3D Sketch, or is that something I do in sheet metal? I'm going to say yes. I can see a possible way of doing that in both environments. Depends on what output you're actually looking for. If you're looking for a flat pattern, then obviously you want to stick with the sheet metal. But if you're just looking for the form, yeah, you could do that with 3D sketching. With the 3D sketch environment, I have seen people build surfaces and just a series of surfaces on surfaces on surfaces and lofted surfaces for bends and radiuses and things like that. And then they end up converting those into thickened faces and they get a solid. So you got a lot of flexibility when you're working with 3D sketching. Can you show the delete face void segment again when you removed the untrimmed portion? Yeah, actually, I can show that real quick. The way that works is you have to have a couple of things in play here. So let me get this out of the way. When you're doing a delete face, find my component now. There we go. Let me get another one here. I think that one, yeah. So if I come in here and I notch out in order to get that set up, so I'm gonna open this component. The reason the delete face works so well in this particular situation, you'll notice that one side of this has absolutely no connection whatsoever to the other side. There's no faces touching or anything like that. In that situation, when you use delete face, you can select the void option. It's looking for a lump or a mass of material that's floating out in space and not connected to anything. In that case, it works. It sees all of that as one massive lump and gets rid of it. In the situation where sometimes maybe these faces are just touching, by definition, they're two different faces, but they're still touching. There's just a little tiny edge between them. In that situation, it can be a little time consuming, but you can use the default delete face option. You just got to pick every single little face that's on this big lump of material out here, and you can't miss any of them, because if you do, it's going to mess you up. You got to pick every single one of those faces and then choose the heal option. What that will do is it will try to delete all of those faces and either heal it up by patching it with material or just removing those definitions and keeping your piece as a solid. You've got to be real careful with heal, because it can destroy or delete geometry that you actually needed. But as long as there's no contact between them, there's a gap between them, the lump option should work just fine. Kevin, you got any others?
Let's see. Eddie Clear's got a couple of questions about the 3D model sketches. Basically, how you initiate the command. The legs that you were drawing at the beginning, essentially. I think, Eddie, if that's what you were talking about.
The 3D sketch is initialized using the same pull down where the 2D sketch command is. So you've got two different icons there. You have a 2D sketch icon, and then just underneath that you have a 3D sketch icon. A lot of people don't even realize the 3D sketch is there, but there is a pull down arrow to the right of the 2D sketch icon, and you'll see 3D sketch listed underneath. Fair warning, when you go into one, it remembers what you were just in and it keeps it there until you switch to another one. So if you start out with a 3D sketch icon is going to be the default icon as long as you have Inventor open in that part file.
Let's see here. And does the BOM take care of beam lengths after delete face is initiated? And I do believe that you showed that that does indeed happen. I know there were way past, 2016 and earlier, we had some little issues with the bill of material not updating, but I think that's pretty well been resolved with the later releases.
Yeah, the base length property was not updating, and I think that was fixed in 2017 update 2, if I remember correctly. One of those updates, update 1 didn't get it. It was either update 2 or update 3 that got it in 17.
Yeah.
To where now it reflects those changes.
Okay. Can the frame be imported into a Revit family for further modeling? I believe those imports are, and correct me if I'm wrong, Kendra, are those imports going from Inventor to Revit would be what we would call dumb solids, are they not?
They're going to go in there as dumb solids, but in Revit, if they come in, it depends on how you get them out of Inventor. If you use BIM Exchange, you can export as an ADSK file, which is going to give you some mapping capabilities for connections and things like that. It's typically used for, like, if you make an HVAC unit and you need to map out hot water supply, cold water drainage, electrical in, things like that. That's going to give you an ADSK file. There's also a way of just exporting the solid or the material out as an RFA, and when that's opened up in Revit, it's my understanding it comes in as a Revit family to where you can do configurations on it for changing size and changing length like that. Some of the properties will come in, but not the features that were used to create it. So a mitered beam, it will come in mitered, but you won't have the miter feature there to delete it or change it. You'll have things like the length and the base sketch representation. That's my understanding of it. I've never actually seen it, but that's what I've been told.
Wonderful. Let's see.
Is the 3D
any
sketch
other questions?
Kevin, did you get this one? 3D sketch mainly used for frame generator. What are other cases the 3D sketch is useful for? Oh, no, it is not just for the frame generator. 3D sketch is incredibly beneficial and powerful when you are working with the cable and wire harness utility in Inventor and the tube and pipe routing utility in Inventor. If you're doing any kind of advanced surface modeling, especially when you're working with lofted shapes. We've got a customer up in the northern states. They do a lot of work with razor companies like Gillette, the handheld electric razors, those free-form, very ergonomic shapes. They do a lot of surfacing to get those shapes modeled in Inventor, and they're doing a lot of 3D sketches for those. Keeping things simple, probably 80% of the time, most people are going to be okay with a 2D sketch, but when you get into some of the special niche fits like cable and wire harness, tube and pipe generation, or advanced shape definition, 3D sketches are going to be beneficial there.
Yeah.
And that looks like I don't see any more coming in.
Not at this point. A lot of compliments, a very good presentation. And indeed it was. I even picked up a few things myself, and I've used Frame Generator for a very long time.
Well, thank you everybody for attending. I hope everybody enjoyed it and got some useful information out of it. Luckily, it was recorded, so you can watch it again in case you missed anything. If you run across something that doesn't make sense or you need some help, by all means, give us a call. We are happy to help out.
Absolutely.
Yes, thanks, Kindred. This will conclude our broadcast. If you do think of additional questions, you can just reply to that confirmation or reminder email you've received from GoToWebinar. We will receive those and get those to Kindred or whoever you need to answer your questions. Once again, if you could take a few moments to answer the short survey, we would appreciate it. We'll just automatically pop up as we close today. Thanks for attending and have a great day, everybody.